Okay, welcome to the Chapter 2 presentation lecture, Creating an Animation Program. When it comes to creating an animation program, there's a couple different steps that we have to go through. The first thing that you're going to want to do is to create some type of a storyboard. And there are a couple of different ways to create a storyboard. Deciding on the problem to be solved, and then designing a solution. When contemplating these two dilemmas, what we need to do is create a storyboard that will first help us decide what the problem is that needs to be solved, and then also the solution that's going to solve the problem. Now, in order to do this in programming, what we will do is we will create a storyboard. A storyboard is a way for us to get our thoughts organized before we actually start coding and writing program code. Now, here's an example, and we will take a look at this because we are going to be doing this coming up here in the near future in class. The scenario is the first encounter. Now, after traveling through space, a robot manned craft has just made a landing on a moon. The robot is on the moon and has set up a camera so earthbound scientists in Houston can view this historic event. The camera view shows the robot, the lunar lander, and some nearby rock formations. Suddenly, an alien peeks out from behind a rock, surprising the robot. The robot looks around, spots the alien, and walks over to take a closer look. The alien is frightened and hides behind the rocks. So the problem is, how can we create this animation? Okay, let's take a look at some possible storyboard options to accomplish that. The first thing that we are going to end up doing tomorrow, or I'm sorry, not tomorrow, possibly in the next couple of days, if not tomorrow, is going to be create the initial world. So this is where we will go into Alice, and we will open up actually a world template that comes along with the textbook. One option is going to be to make sketches. So you can sketch with a pen or pencil, you can actually draw the picture. So here is an example of what the scene is going to look like. You can see that there's the USA object over there, there's the robot, and then there's also the alien behind the rocks. So the description that's going to go along with the picture is the alien peeks up from behind a rock, there is no sound, and the text, which is what the alien is going to say, is Slippy Toes. Now another option is to take screenshots to create a storyboard. So you can see the picture for the initial scene, which is the space background with all the objects in it. And then the second picture is going to be a picture of the spider robot walking towards the alien while the alien pokes his head out from behind the rock. Now, there's also a third option for writing storyboards, and that is to actually do it using text. So now when you're writing text, it's like with our pen activity where you're actually writing the instructions down on paper, organizing your thoughts so that you can then put them into code and have the code be executed by the program. The Learning to Program in Alice textbook puts a textual storyboard in a box, such as the example here. So what you want to do is you want to do these steps in order. You want the alien to move up, then you want the alien to say Slippy Toes, you want the robot's head to then turn, you want the robot to turn and look at the alien, and then simultaneously, which means doing at the same time or do together, robot's going to move toward the alien, robot's legs are going to walk, and then the alien is going to move down. So there is a sequence of events. Those are the instructions. That's the storyboard put together, organizing the thoughts before we actually put in the program code. So that's what Chapter 2 is analyzing storyboards in order to turn it into program code. So after we have our storyboard, the next thing that we're going to do is we are going to implement the storyboard into code. So to implement the storyboard, we need to translate the actions that we had written down, our thoughts, whether or not it be pictures, illustrations, or text, and then create a program script. A program script is a list of instructions that is going to dictate how the objects move within the world and what certain actions is going to happen within the animation. So to do this, we are actually going to start looking into our coding window. Our coding window is going to be titled My First Method. So this is where we're going to put all of this code. Method is a block of code that is going to be executed when we tell Alice to do so. What we are going to be using is sequential action blocks, which are laid out in the chapter in your textbook. Sequential action blocks, also known as control structures, do in order, do together, are the two that we are going to use for this example. Do in order means do these actions, and then once one action finishes, do the next. A do together is when actions happen simultaneously. And as you'll see as we go through this, you can nest control structures within each other. So you can nest a do together in a do in order. You can nest a do in order within a do together. All right, so then what we will be doing within the next day or so, possibly even tomorrow, is we will be doing the first encounter example in class. We will be running through this so that you can see how we can put together the storyboard, and then also take that storyboard and turn it into program code and execute it the way we want it to be executed. After we have completed the demo, or while you are completing the demo, these are the things that you want to keep in mind. First of all, what exactly are program instructions? Program instructions are arguments. Arguments are going to be used to manipulate objects, to move them around the screen, to have them interact with each other. So example, for the move instruction, the arguments that we are going to use in this example are direction and distance. So when we are telling an object to move, we have to tell it where to move, and we have to tell it how far to move. Do together and do in order blocks can be nested. I talked about this on the previous slide, which means you can have a do in order within a do together, and you can have a do together within a do in order. Once you have the program code written, then the next step is going to be to test it. So an important step in creating a program is running it to make sure that there are no errors. It's recommended that you write a few lines of code and then run it to make sure that your code is executing correctly before moving on to a next set of code instructions. Write a few more lines and a few more lines, run it until you have the code completed, you have the program running the way that you want it to run, and there are no errors. This process is going to allow you to find any problems and fix them as you go along. It's a very, very smart process to help limit the amount of errors and at least be able to fix them with looking at very limited amount of code. Think about running an entire program and then going back and trying to find the errors, how much code you have to sift through. So if you do a couple of instructions, run it, okay, yep, that looks good, running well. Now move on to the next set of instructions. That's a good process and a good habit to get into. Also, don't forget, as you are running these programs and as you are writing code, save often. Every once in a while, you might find that Alice is going to crash on you and you don't want to have to recreate everything from scratch. So make sure that you save often. We will talk about, as we go through this example in class, is comments. Alice instructions can be easy to understand, and usually one coder to another coder will be able to understand what is going on within the code. However, you might not be the only one who is working on a particular computer program. So if you and possibly other team members are going to be working on program code, you're going to want to put in their comments. Comments are going to be used to document the code and explain the purpose of a particular segment of the program to a human reader. This is going to allow anybody working on the code to understand what is going on with this particular block of code, make adjustments, make corrections, make improvements as needed. And then the demo that we will work on tomorrow will include comments. We will go through writing all of the code. We will also start inserting comments into the code so that it is easy to determine what is happening in certain block sets of code. Comments in the example are going to illustrate the description of the action performed by the entire method, as well as a description of the purpose of a small segment of code. All right, so if you haven't already done so, please make sure that you read Chapter 2, Sections 1 and 2, look through the scenarios and storyboards, look through a first program, and then also take a look and browse through the Reads, Tips, and Techniques 2, Orientation and Movement Instructions. When we get to class here in the next couple of days, what we will be doing is we'll be working on examples to practice these different tips and techniques and different programming using storyboards. So make sure that you're familiar with it. And then finally, at the end, you'll be assigned a Chapter 2 lab, which you will be completing individually. So you will get a couple of different program scenarios, and then you'll be asked to write the code and get your program to execute correctly. Okay, so that concludes the presentation lecture for Chapter 2. Again, please make sure that you are prepared for class tomorrow. And tomorrow we will be doing, or tomorrow or the next day, as soon as we can get to it, we will be working on the in-class demo first encounter.